Welcome back. In the videos so far, the process that we've gone through for problems that start off stated as a system of linear equations, that process for solving that system is called Gauss-Jordan elimination. The first step is to convert the system into a augmented matrix. Well, actually the first step is to make sure the system's in standard form and that all the equations are linear so that this process can work. Once we've made that confirmation, which may be called step 0, then we create the augmented matrix from the SLE. We row reduce like crazy until we can't go any further. We have all the leading ones that we can possibly have, and all those leading ones are happy, and all the 0 rows are at the bottom. Then we translate what that row reduced system of, or what that row reduced matrix means in terms of solutions to the system of linear equations. Sometimes that involves introducing parameters. Sometimes that just means stating what each of the variables is equal to in terms of a number. Let's do another example. I'm very, very worried when I see this. I see 4 equations with 3 unknowns and some large numbers. I'm worried about making a mistake. That's what my concern is. Anyway, my first step is going to be to convert this. I'll do it underneath. I'm going to convert this into a matrix, column by column. So 3, 1, 2, minus 1, 3, 1, 5, 2, 12, 4, 28, vertical line, 6, 2, 10, 4. All right. I want a leading 1. We have a leading 1 in row 2, but it's not in the right position. So the first move is we should swap row 1 and row 2. Row 1 swaps with row 2. So the new matrix is just a copy with those 2 rows switched. 1, 1. I gotta write smaller because this is going to take up a lot of space if I'm not careful. 1, 1, 4, 2. Then I'll run out of space. 3, 3, 12, 6, 2, 5, 20, 10, negative 1, 2, 8, 4. All right. There's so many options we have at this point. What I see immediately when I look at row 2, I see that every number in that row is a multiple of 3. The larger the numbers that you're working with, the higher the chance that you're going to make a mistake. What I'm going to do is I'm going to do what seems to be a non-required step. I'm going to replace row 2 by row 2 divided by 3, just to make those numbers smaller. Now, if that 12 was an 11, I would never dream of doing this because that will create a fraction. Now, imagine doing all these elementary row operations with fractions, making common denominators. It's not that it's impossible to do, but do you want to? So as you follow along in these methods, as you follow along in these solutions, you'll notice one of the driving features of the methods that I'm using, or the approach that I'm using, is that I'm desperate to avoid fractions at all costs, unless we're stuck with it at the end somewhere. And I recommend you do the same thing. If you are tempted to do a move that will create a fraction, reconsider it. Try something else. So row 2 gets replaced by row 2 divided by 3. And we're not doing that to create leading 1s. We're doing that, and we could have done that at the beginning. We're doing that because it just makes the number smaller, and I didn't notice it until doing that row swap for whatever reason. We could have started that way. So 1, 1, 4, 2, 1, 1, 4. So I'm dividing by 3, I get a 2. That's interesting. I wonder what that means. I see 2 rows that are the same. Well, I have some sources of unhappiness. Let's get rid of them. Let's make that leading one on the top left happy. Unhappy sources. I'll call them sources of unhappiness. Sources of unhappy. We want that leading one to be happy, and those can't stay. They have to be 0. Okay, so we'll do 3 moves in 1. We'll do a triple. We'll replace row 2. We have to make that 1 a 0, so I'm going to replace row 2 with itself minus row 1. Always using the leading one as the weapon. I'm going to replace, well, I'll do that move first and then write down what the other moves are, because it gets more confusing if I don't. So the row 1 is going to stay the same. We're not changing that row in this move. We're using it as the weapon. Row 2, 1 minus 1, 1 minus 1, 4 minus 4, 2 minus 2. It's all zeros. That's not a problem. Perfectly fine. It happens. It just means that those rows contain duplicate information. If you think about the shopping list, that first person bought 3 times what the second person bought in the original SLE. And their numbers are all in agreement with each other. The first person paid $2 for what they bought, and the person at the top paid $6, the person beneath them paid twice, or paid $2, and one bought 3 times as much and paid 3 times as much. So they're consistent information. They're not adding additional information. One is not saying anything else than what the other one is saying. That's why we're getting that row of zeros. Now the next thing we're going to do is I'm going to replace row 3 with row 3 minus 2 row 1. So we have 2 minus 2 times 1, which is 0. 5 minus 2 times 1, which is 3. 20 minus 2 times 4, so 20 minus 8, which is 12. Uh-oh, don't go there, I'm not done. 12. And then 10 minus 2 times 2, so 10 minus 4, which is 6. And I see another opportunity to divide our row by a constant to make the number smaller, and we'll do that. We'll do that as another step, but not the next step. The next step we have to continue. We have to fix row 4. Row 4, we're still inside this step. We're not done. We're going to replace row 4 by itself. And how do I turn that -1 into a 0? Using the weapon? Well, I'm going to add row 1 to it. So row 4 plus row 1. Always use your leading one as the weapon to zero out the numbers. Don't start using other rows to do that. You'll screw things up. Okay, so 1 plus -1, 0. 1, I mean, you can, but don't. It's not that it's wrong, it's that you're going to start confusing yourself. 1 plus 2, 3. 4 plus 8, 12. 2 plus 4, 6. And I take it back. I'm not going to do the next move as dividing row 3 by 3. Make the number smaller. Because look, we got duplicate rows again. I'm going to do the next move. I'm going to subtract. I'm going to replace row 4 by row 4 minus row 3. Zero it all out. At this point, someone should put their hand up, but you can't because this is a video. Someone should put their hand up and say, how come you haven't moved that 0 row to the bottom? And I'm supposed to go, excellent question, how come I haven't? We will. We'll just do it in a moment. So I'm going to replace row 4 with row 4 minus row 3. And I'm only doing that because these are duplicate rows, and I can zero a whole bunch of stuff. Okay, and then what do we have? We have 1, 1, 4, 2, 0, 0, 0, 0, 0, 3, 12, 6, 0, 0, 0, 0. Okay, now I'm going to do a row swap. I'm going to swap row 2 and row 3. Because we want the 0 rows at the bottom. 1, 1, 4, 2, 0, 3, 12, 6, and then 2 rows that are all zeros. Excellent. Okay, and then the next move, I have a happy leading 1, and yes, I can divide by 3, but I choose not to. We have a source of unhappiness. I'm going to destroy it. Source of unhappy. So the move that I'm going to do is I'm going to replace row 2 by row 2 minus 3 row 1. And again, yes, we can divide by 3 first and then do this move. It's a choice. Like I said, there's many paths to the answer. As long as we don't break any rules, we'll all get there, and no matter which path we follow. You may have already beaten me. You may have done this on your own. I have 1, 2, 3, 4, 5, 6. I have 6 steps, and I'm going to need a 7th. You may have solved it in 4, because I think you can do this one in 4. 1, 1, 4, 2, 0. Oh, actually, I can't do that. Look what happens if I do that. I make my leading 1 unhappy. My top left leading 1. I can't do this. I gotta go back. I should end up actually dividing by 3. My intuition was right. So we'll divide. That wasn't a source of unhappy. I just confused myself. It's perfectly happy. 0, 0, 3. Okay. So I'm gonna make a leading 1 at that position where the 3 is. Create a leading 1. Create leading 1. It doesn't even know it's unhappy yet because it's not a leading 1 yet. So I'm going to replace row 2 by row 2 divided by 3. So 1, 1, 4, 2, 0 divided by 3 is 0, 3 divided by 3 is 1, 12 divided by 3 is 4, 6 divided by 3 is 2, and then 2 rows of all zeros. All right, and now we have a source of unhappiness, and it's up here. Source of unhappy. Okay, so what we have to do is we have to zero it out. We're going to replace row 1 by row 1 minus row 2. That'll cause that number to zero out. And what do we get? Running out of space. That's okay, because I think we're done. Oh, sorry. 1 minus 0 is 1, 1 minus 1 is 0, 4 minus 4 is 0, 2 minus 2 is 0. And row 2 doesn't change. And it's fully row reduced. We have 2 leading 1s. Above and below are 0, so they're happy leading 1s. We cannot create a leading 1 in the 3rd column. Like for example, we can't put 1 here. There's no number there. It's a 0. We can't turn that into a 1. This 4 can't be a leading 1 because it's not the first number in its row, so I can't do anything with that. I can't do anything down here either. I can't turn that into a leading 1. So this is the maximum number of leading 1s I can possibly have. What we have left is to solve the system, or to state what the system is in terms of its variables. This is an x, this is a y, this is a z. It's also a t column because there's no leading 1 inside column 3. So row 1, it says the following. It says that x is equal to 0. 1 times x plus 0 times y plus 0 times z is equal to 0. Perfectly fine. And then row 2 says that y plus 4z is equal to 2. But z is a parameter column. It's t. So y plus 4t is equal to 2. And that means that y is equal to 2 minus 4t. And since z is a parameter column, z is equal to t. So that's our solution. I just don't have space to write it in vector format. as x comma y comma z is equal to 0 comma 2 minus 4t comma t. How would you check? Since there's t in here and there's actually t in here, it's cold now. How would you check? What you would do is you would substitute x is equal to 0, y is equal to 2 minus 4t, and z is equal to t into each of those equations. I'm going to do one. I'm going to do a quick check up here. Just in equation 1, so 3 times 0 plus 3 times 2 minus 4t. I'm really paranoid that I made a mistake, so this check is not 12t is equal to 6. So 0 plus 6 minus 12t plus 12t is equal to 6. 6 is equal to 6, true. So it's not a guarantee that we didn't make a mistake, but I probably got it right. If you want to check them all, go ahead, but that's what we're trying to do. We're trying to find all possible solutions. So notice that when there's a parameter, when there's a family of solutions, you have a choice for any t value that you want. That check was independent of the t. We could put a 10 and it would still cancel out. Put a 5 for t, or 2, or a 0. They'll all work. You have a different number of choices, but there's an order to the chaos. Whatever you choose for t is going to determine what happens to y, and in turn what happens to z. We'll do some more examples in the next video.